More than welcome, Professor Thomas. And the mic is with you to introduce your guest.
All right, yeah. We have 3 guests with us today. Florent Pon from France, who's been a near friend of mine, a practitioner / academic that really understands how to get things that work in the real world as well as the theoretical world as well. Paul Room is with us from DHU3, and Peter Tyler and Giorgio Caselli will be from Cambridge. They'll all be talking to us. So please elaborate some more on the introductions for me. And Florent, I'll leave the microphone to you.
Hello. I'm really honored and pleased to join here. Hello, my dear friend Tomo. You miss me, and I miss you. But I'm here to share about my findings as practitioners as well as theoretician. I've seen more than 400 venture projects in my life. As innovation director for the French Aerospace Research Center, as well as member of the European Innovation Council jury.
عضو في البرلمان الأوروبي.
Sorry?
Yeah.
Could you put yourself on mute if you're not talking, please?
From English into Arabic. Go ahead.
Okay, so I will try to share my screen.
سأحاول مشاركة الشاشة معكم.
Yep. Do you have my presentation?
Yes, go ahead.
Excellent. So I will share about my findings related to what I discovered
سأشارك
as
نتائج
new
الدراسة
practices in the
معكم.
innovation nowadays. Just to fix the innovation, it's not only ideas, new method, it's creativity plus value. I had the chance to have professors like Eric von Hippel at MIT, which define innovation in only 4 keywords: successful exploitation of a new idea. Just to remember what means value in socio-economic terms, and value means the commercial capital, access to resources, and also human capital. The last 3 for the Nobel Prize, Amartya Sen, are building the so-called dynamic capabilities. Take care to the word dynamic, because this means what you have today, tomorrow probably you don't have it, and vice versa. Is the value material or intangible? And of course, the answer is both. You just could see the IP and how much it could worth when you sell IP. Why? Because it's providing to you trademark, it's providing to you capacities, exclusive use of some technologies, and of course, it's providing to you secret know-how, which since '98 and the agreement of Marrakesh, is part of the intellectual property and recognized like this, so you could make transactions with them. Information, for sure, information is value. If you don't believe it, look at Twitter, who disclosed the first beneficial exercise in April 2018, and before this they lost hundreds of millions, still valuing more than 10 billions in the stock options. So it is not because, hi, I'm Paris Hilton drinking a champagne cup, which is the majority of the 160 million tweets per day, but 4% of the tweets per day are pure opinions, so very high value in marketing. And so the artificial intelligence was able to extract this information from the ocean with fake and narcissistic news. They got the money, so they become beneficial. But to be more provocative, including stress avoidance, it's money, it's value. Because if you don't believe it, just please take a low-cost airline company, and you will understand that if you want comfort, you will start to pay. At the end, you pay for your luggage, you pay to be seated next to your friend, and so on. At the end, you pay the same amount as you pay for Air France, but at least you know why you paid. I just give the example of Ryanair. Another fundamental, just to fix all the ideas, is the technology readiness level scale. I don't know elsewhere, but here in Europe, nobody could get money to innovate without making reference to this scale. So you have call for tenders for projects from TRL 5 to TRL 8, TRL 6 to TRL 9. You have consortium R&D agreements for TRL 2 and TRL 3. So if you don't know where you position yourself on the technology readiness level, you have no money to innovate. Here I reproduce the exact original thermometer of technology readiness level. This is why it's so impregnated with space ideas, because it was published by Mankins in '85 at NASA. But I will do it differently. So in level 1, you have basic fundamental research. In level 2, you already have the applied research. Technology readiness level 3 is the famous proof of concept. If you heard about proof of concept, this is it, TRL 3. TRL 4, laboratory prototype. 5, you are doing robust design. You integrate tolerances from components, both on the market, premises of the supply chain, by the way. 6, it is working in operational condition for what it has been imagined in TRL 2. So it is the famous so-called demo tech. In 7, you packed everything, the wires, and it starts to look like a product. It's the so-called industrial prototype. Now it's good, you did once, please make me 10,000. This is TRL 8, setting the production. And in 9, well, in 9, you certify that each of the product among the 10,000 you are able to build per month or per year are respecting the norms. So you are entitled to sell with the UE stamps or American stamp in these countries. And of course, all other countries have their norms and regulations. These are the number of ideas falling down to a potential product or service. And these are the curve for investment. First sales in TRL 9, you still invest a little bit more for commercialization, marketing, distribution, promotion. And we all hope here to pass in plus, but we are all living as innovators somewhere here, which is the so-called Death Valley. These are the related level of risk you assume when you take decision to invest, to go from TRL 3 to 4 to 6, as for example. The level is quite high because you still have a risk on technology, but also on the market. Here, you don't have any more risk on technology, but you still have the market risk. And then it is very high on this level 9, because it's where you scramble all the money. You put all in and you launch the product. And if you have a bad advertising campaign like Mitsubishi Pajero, which for Spanish native speakers, they could understand Pajero, it's a very pejorative word. Well, the best off-roader in the world who won 7 times Paris-Dakar, you don't sell it. You don't sell it much more than the Nissan Patrol or Toyota Land Cruiser because of the name. So here you scramble all the money, and doesn't matter if you have the best technology in the world, you could not sell because it's a bad advertising or a bad value distribution channel understanding and so on. I just want to highlight here the fact that you need the only person, each level you change faces, you change actors, and we'll see it. The only one remaining on board is the entrepreneur, or within big companies, the so-called intrapreneur, the program manager. And unfortunately, very few big companies are recruiting their program manager based on their entrepreneurial skill. And by the way, they need to take the best of each of the actors they meet at each of the levels. So they need to make the others working more than their best. So this is the definition of an entrepreneur. By the way, I'm quite proud, Cocorico, I'm French, and this is a French word, semantically, entrepreneur, which means between parties taking part to a value creation process collectively. Okay, move more. I put the TRL down to make an analysis and positioning the actors. Here you have the public R&D laboratories, some applied laboratories R&D, Carnot Institute in France, Fraunhofer in Germany, and so on. They are able to do the proof of concept. They shook hands with large industrials which have their applied research here generally when they are within their strategic roadmap. Here, some large industrials are very efficient in technology scouting globally, so they could take demo techs coming from elsewhere and put them in competition with their own developed demo techs, and the best to win. Startup business is to take something from laboratory and made with the money we'll see of the business angel, the technological demonstrator, and then to develop themselves on a niche market or to make a venture with a big guy on a big existing market or disrupting the market if they could. Small and medium enterprise, well, very few of them have capacities to discuss with the public and the research laboratories. So that's why, additionally, here, specifically in Europe, except in London, which is not part anymore of the European Union, we don't have business angel money. We have an equity gap here. So all the states and the European Union are putting money here in the famous so-called seed money. Well, we definitely need dedicated structures with collaborative tools, and I will present the demand readiness level versus technology readiness level method. So as a new trend, it was adopted by a lot of business angels and investment funds as a tool to measure when they do invest or not in innovation. But this graph, it's very some asymmetries in terms of Joseph Stiglitz creating value, which means value based on a new idea, which means innovation. So together with the information asymmetries between the two parties, you have the technological asymmetries, which is very well positioned here, at least for the small and medium enterprise. Risk, temporality, the R&D works more with 3 years of the PhD in their mind as temporal unit. The small and medium enterprise, they need a solution for yesterday. Risk on investment for sure, and also culture. From Veblen, the people are shared in two distinct categories: the workmanship, creative guy, and the predator, the opportunist. I'm taking this back in order to introduce the revenue curves, the expenditures, the cash flow, and the return on evaluation on investment, because we do believe that the plus here has to be bigger than the minus, and we are doing everything for doing this. As I mentioned to you here, you need collaborative tools, which means tech transfer offices towards SMEs inside the laboratories, incubators for startups, and business angels or public-private partnership for funds here. There you have the Series A venture capital to launch to industrialize the product. And there you have the so-called scale-up accelerators. I know good scale-up accelerators only in the United States and in Israel. This is the so-called scalarator, because when you have to cross the chasm here, everybody expects such an explosion, smooth curves, but things are happening like this in real time. So that's why you need professional scale-up accelerators. Now, we had seen a lot of concept based on TRL. Just to tell you that I am the lucky inventor of the demand readiness level. When you put this, I will let the slides so you could go into details. We don't have time to detail each of the levels. but you need to remain on. You identify a specific need, then you identify the functionalities which will fulfill the need. Then you will be able to translate the functionalities in needed capabilities to be the answer. So at Tonera, we after doing the work, I discovered that we are able to transfer technology at each level if the sum of the project is bigger than 9. Okay, so like this, you could invest blinded eyes, if I would say. If the DRL plus the TRL, it's more than 9, you could go for, it will be a success story. If I'm complicated things, I putting this in 2D, you could have an innovation process readiness diagram where all the bubbles here are bubbles filled with actions to be carried in order to reach the first sales with success, okay? Again, I will let you this, and each of the action could be explained, and this is the action you need to make in order to bring to the normal flux of the innovation in order to have your first sales. Some diagonals very interested. These are much more demand market pull projects. Here are technology push projects. Here is the transactional innovation, and here you are alone. One last slide. Everybody is speaking about the value distribution channel. For a passenger putting €100 here, Airbus is taking, or Boeing is taking 7. At Tonera, which is the National Aerospace Research Center, we take 2 cents. Is not anymore a value distribution channel because it starts to be like a tree, which is distributing the money to several routes. And these routes are connected because BMW Design Office conceived the cockpit for the most trendy business jet, which is the Dassault Falcon 6. So these trees are interpenetrating and they are reaching the other trees. And of course, we have the tsunami here down, like a rhizomial route, which is the digital world, which is impacting everything. And like this, we are in a kind of enchanted mango forest, which is distributing value because the money is still flowing like a rain up. And everybody will have some money depending where he's positioned on a branch or on a route. Why it's happening? Because these tubes are not more sealed. Since Professor Cheslow demonstrated, we are all in an open innovation world. Everybody could supply everybody very fast nowadays. And these are impacting directly the business models. As for example, here, as soon Amadeus create dynamic pricing for airlines, he's taking 2.5% from a ticket, more than 1/3 from an Airbus, just for selling ticket, very smart. You also have the onboard connected pads. You could not buy anymore a car with a pad, tactile, with a screen mirroring on your smartphone. And we are speaking about the car. And we don't speak about Tesla, which is a kind of giant iPad on 4 wheels. And when the car will be autonomous, you will buy software and transportation means for sure. And this will impact all the manufacturer of cars, which will not sell cars anymore. They will sell mobility. So if you don't believe, look and ask Volkswagen why they just bought Europe car. So they will become fleet manager because an autonomous car, it will not be anymore a social object like nowadays a car is. It will be an utility object. So I will not buy anymore my car. I will use cars. Let's go for more. So we are.
I think we got. I have to cut you off, Lauren, because it's time to our next presenter.
Okay, it's over. It's just
send Lauren questions in the chat.
Okay.
Yeah, send him questions in the chat. That might be the best way to do it, so we can get to everybody. We have 2 more speakers to go. With that, I'd like to present Paul Groom. He is the founder of DHU3, and I'll give the floor to him, and hopefully he can introduce himself a little bit more. Hey, Paul, you have the floor now. Thank you, Florin, by the way. Excellent presentation, as always.
Hi, good evening to everybody, and welcome. Thank you for the invite to present to you all. Just bring up a proper pointer. So, as indicated, my name is Paul Groom. I'm the director of DHub, spelt DHU3, but short for Digital Hub. And I'm the Middle East representative partner for Ocoda. So we've got 3 days of innovation, AI, entrepreneurship. And in 20 minutes, I would like to explain why O as a software language is at the core of everything you and your competitors are currently or planning to achieve in the coming years. Fascinating facts on AI from Dr. Zara earlier, that there are going to be 97 million new jobs in 2025 in AI. What should be mentioned at this point is that everything is driven by coding, software development, whether it's AI, IoT, and the digital transformation process that's going on around the world has actually led to a shortage of developers. At any one time, there will be 20 to 30 languages that are popular with developers around the world. Some fall off, some are added. And as a computer scientist going through university, the question is, which ones do I learn? Do I learn 1, 2, 3? Do I want to be back-end developer, front-end, and so forth? So Ocoda, a company in Manchester, was formed by Dr. Raj Kerwin some years ago. Dr. Raj is an expert and one of the smartest individuals you will ever wish to meet. He decided many years ago that there is a better way. And that better way is to invent a language that can satisfy the full stack and can operate as a translator for code. So with one single language, it can operate and produce native code in multiple languages. It has been developed over 6 years, providing for many blue chip companies in the UK, Metropolitan Police, HMRC, PwC, and many more. Let me just take this out. Our partner program, as we've been developing this through the course of the last year or two, particularly in the Middle East, has been working with universities and government ministries to create a journey from learning through to employment. And instead of that being operated in silos, we have created a throughput, teaching university graduates or upskilling current staff free of charge. We don't charge ridiculous fees for this training. It's free to all. And through that development path, I will now take you through the journey. So what is O? It's a programming language. It's a mature language. We're now on version 3.9.1. And we, over the past number of years, have written millions of lines of O code, which has created, generated hundreds of millions of lines of native code. It does this in a compiler, and the output languages, you can see some of them here from Node.js, SQL, MongoDB, PHP, Python, and so forth. And the reality is that with O, you actually write 71% less code in 40% less time with a smaller, more agile team. What that enables is efficiency. Efficiency on cost, efficiency on time, and efficiency on getting the product to market ahead of the competition. And what it enables the world to do is now learn with one language that covers the full stack, and it enables the sort of youth coming through the university system to look at software development no longer as a geek subject, but as something that has got demand written all over it, from gaming, AI, IoT, and many more. It's not a low code, it's not a no code, even though Dr. Did say that the AI trends are into that direction. But if you're a government, if you're a large corporation, you want something that's not brittle, you want something that's robust and sustainable. So how does O help with development? It's a browser-based language. There's nothing to download. It's a single IDE. It's Git-backed, and each operative has their own desk, username and password protected. So the autonomic IDE, it's an elegant language. As I mentioned earlier, it's 4 times faster. But the training through the O Elite program can be done in a self-paced 12-week supported program, which we do with weekly webinars, Q&As, buddy group support, or it can be done in a 2-week intensive program. So in just 2 weeks, you can learn a software development language that enables you to cover the full stack and enables you to become a developer dealing with real-world projects from the get-go. So the O Elite, we have an output when they graduate to join the team, and our community is something I'll talk about in a minute. But the Ambassador program really enables them to support the new graduates coming through. We run internships and then train developers going out into the world. So O actually translates into whatever language you want. It can be operated side by side with existing development teams, or it can be operated autonomously. I mentioned the community. What we're here doing is we're taking fresh young grads, teaching them O, and then they're getting involved in real world projects. However, during that journey, we are creating job cards for the developers, which will showcase digitally the skills that they have learnt and show the real code that they have written. And this will be showcased on an international job portal, which is meeting or matching the skills of the O developers and allowing employers to come in and match their needs to the skills available. So we provide better tools, better training, and a better community. So how can O be used with an existing business? As I mentioned, we can upskill current staff free of charge. So a back-end developer can then become much faster, more quicker, and they can also operate in the full stack. So we can train existing developers as well as encourage the employment of new. And this is very important that this can be done quickly with current and new to meet the shortage of developers globally and things like these 95 million people that are required in AI. The output collectively of universities globally across all subjects would struggle to meet that demand. However, what we're aiming to do is to not only to teach computer science, but mathematics, physics. Anybody who's problem solver can actually get involved with software development. The key is delivery, it's speed. Speed is a currency that's taking over the world. If you Google something, you get 4 million results in a nanosecond. The youth of today want information instantly. They are demanding speed, and companies are demanding speed in getting product to market. So using traditional languages in a traditional dev team, rarely delivering on time, rarely delivering to budget. The new way is working with the O language, enabling smaller teams to be more agile, delivering on time in full. So bringing these guys up to development quickly. The current cohort that we're training, we had registrations across 14 countries, over 130 developers, brand new developers. And as I say, we'll take them through their job cards into the job portal. But we teach them the programming basics, the documentation, the organization, putting it into skills, and then writing implementations and getting involved in projects. So here are some live examples. Nargis was a graduate from the University of Bahrain who joined us just 1 year ago. And in 12 weeks, she was a junior developer, joined D-Hub as a full-time employee, and she's now working on real-world projects with the UK, and has recently completed a project for a company called Lionfish. So along with 5 developers, they actually wrote 22,000 lines of O, which generated 153 lines of native output code. So the efficiency of that for the client was getting their product to market. Tom has worked with us. He did a 2-week intensive program. He's just worked on a project recently for SSCL with 3 other developers, 10,000 lines of O, generating 68,000 lines of output code. Will, smaller program, smaller team, very quick, 1,600 lines, generating 14,000 lines of output code. So one of the things is supporting business, but it's also getting developers to revenue generation. I've given you some examples, but how resilient to change. So here's an example. A company may train a number of developers internally. They are required to write iOS applications, and they start that quite happily. However, Apple decide to make a change, as they did in 2020, to Swift UI, which means that that development house has got to retrain all the developers so they can then start generating iOS applications in 2022. With O, it's slightly different. The O developers create the iOS applications using whatever languages are required by the development house or the client. And by the way, if somebody wants an Android application, then with 1 line of code change from the iOS version, the O compiler will create the Android application or the web service application. So when Apple make the requirement, the Otron developers will rewrite that into the O compiler and the implementations. The developers won't know that's happening, but as they write or recompile previous applications, they will automatically include the new Swift UI or whatever upgrade has been required. The efficiency of this is enormous. There's no retraining. There's no clients going back to dev houses saying we need this upgrade at ridiculous cost and time. This is done automatically. So we future-proof software development. How do we measure success? It's in trained developers, writing less code in less time, being more efficient, and enabling the local development community to grow in whichever country. So in the MENA region, we have Saudi Arabia with Saudiization, Bahrainization, and looking to reduce the offshore development that has historically been done, but employing locals to be able to satisfy the technology demands that are coming through public and private entities and enterprise currently and in the future. So what does success look like to us? It's about people, it's our community. So our community includes ministries, graduates coming through who are saying, I thought they were kidding when they said you could learn to code in O in 2 weeks, but they weren't. The university graduates coming through and being in a community with such an amazing vision for the future is truly amazing. Learning O was the most fun I've had during my time developing. The language was intuitive and I had a blast learning it. And reaching that level of proficiency and speed in such a short period of time would be unthinkable in any other language. So for us, happy clients, happy developers, and a growing local community satisfying local needs is how we define success. So any questions, please send to paul@dhub.com, that's DHU3. And please remember, our mission is about empowering youth to be the next generation of software developers for the next generation of applications, and growing the local community is hugely important. So I'll transfer you back to the host. Thank you very much for inviting me today. I hope you found this motivational and a little bit interesting. And I look forward to hearing from you.
Thank you. We have about a minute if anybody has a quick question before we move on to the next presenter. Not, please use the chat mode to send questions so we can answer that way. The next presenter will be Giorgio Caselli, and he is a research fellow at the Center for Business and Research and postdoctoral research fellows at St. Agnes College, University of Cambridge. All right, Giorgio, please.
Yeah, thank you very much, Thomas. Can you hear me well?
Very well.
Fantastic. Well, first of all, hello, everybody. It's a pleasure to be here today. So I'm Dr. Giorgio Caselli. I'm a research fellow at the Center for Business Research of the University of Cambridge. And I'd like to start by thanking, also on behalf of Professor Peter Tyler, who is with me today, Dr. Hanadi Al-Mubaraki, for inviting us to deliver this keynote speech. So our presentation today is based on an ongoing research that Professor Tyler and I have been doing together with Dr. Andy Koch, also from the University of Cambridge, to understand why the Cambridge innovation ecosystem has been so successful. We also recently published an article exploring some of the issues that we will be discussing today, which is available to download on the Hoover platform. After over some 60 years, we think it is now a good time to take stock of the factors that have been associated with the success of the Cambridge phenomenon. Our research is seeking to establish the relative contribution of the people, businesses, and institutions that have come together in Cambridge to create what has become known as the Cambridge phenomenon. And we should be clearer about it in a few seconds. So in the research presentation today, we discuss some of the features of the Cambridge experience that have contributed to its relative success, focusing specifically on how the business base has evolved over time, as well as on the geography of the cluster. So last year marked the 60th anniversary of the Cambridge phenomenon, which is a term many of you may be already familiar with, which was first adopted in a 1980 Financial Times article to describe what was the rapid growth explosion of high technology companies in and around Cambridge. The cluster has now grown to become one of the leading high technology clusters in the world and is home to over 30 science campuses, including the Cambridge Biomedical Campus, which is Europe's largest healthcare and medical research center. It comes with no surprise that the Cambridge phenomenon has been able to attract increasing attention over time, including a number of excellent contributions providing an overview of the phenomenon, such as those by Kate Kirk, Charles Cotton, SQW, and David Gill. However, we think that there has been less evidence to date on how the business base of the cluster has evolved over time, as well as on how the innovation system has developed, particularly as it relates to how the public and private sectors have worked together. So the Cambridge ecosystem has been decades in the making, and indeed did not originate from an ordered or planned process, but instead developed organically out of what we may call creative chaos. In our research, we identify the key elements that have determined the success of the cluster. So a first element is a series of scientific breakthrough that established Cambridge as a leader in information technology and computing. Perhaps the most famous example is the ETSAC, which was the world's first fully functional stored program computer, which was built by Sir Maurice Wilkes and his colleagues at the University of Cambridge's Mathematical Laboratory. Along with this scientific breakthrough, at the heart of the Cambridge phenomenon was also the founding of several technology consultancies, such as Cambridge Consultants, PA Consulting, Sagentia, and the Technology Partnership. A third element was an accommodating land use policy as reflected in the creation of the Cambridge Science Park by Trinity College, one of the 31 colleges part of the University of Cambridge, in 1970, which is credited with kicking off the Cambridge phenomenon. The adoption of a flexible and encouraging IP policy on the part of the University of Cambridge also played an important role. And indeed, there are numerous examples of startups that spun out of the university in order to commercialize an idea that was initially developed as part of academic research. And financial and other support has also been provided to startups via Cambridge Enterprise, which is the commercialization arm of the University of Cambridge. And the availability of finance for companies to grow is itself one of the key elements behind the success of the Cambridge cluster. So among the main investors in the cluster are Cambridge Angels, which is a leading Cambridge-based business angel network of more than 60 high net worth investors, and Amadeus Capital Partners, which is a venture capital firm investing in high technology companies. And the Cambridge innovation ecosystem has also benefited from research and public funding from a variety of organizations, including the Biotechnology and Biological Sciences Research Council. Equally important has been a culture of mutual support and collaboration, which has been nurtured by several membership organizations such as Cambridge Network for the Technology Sector, One Nucleus for Life Sciences and Healthcare, and Cambridge Wireless for Information and Communication Technologies. As shown in this slide, the number of factors making up the Cambridge innovation ecosystem and the complexity of the interactions among them have increased substantially as the ecosystem developed. To make sense of this complex reality, we can say that behind the Cambridge phenomenon are 4 key systems containing the people, businesses, and institutions that have come together in Cambridge to translate knowledge and ideas into outcomes that have enhanced societal well-being and generated commercial success. Our focus today will be on the business system. So how has the Cambridge business base evolved over time? Well, early assessments of the size of the cluster indicated that there were about 300 high-tech businesses in Cambridge in 1985, and we should remember that the starting year or period was 1960, And that set of companies was made up mostly by quite small R&D-driven companies, often academic spin-outs. And there was also a limited number of large companies that tended to dominate employment during the 1980s. So very few companies with a limited number of large companies dominating employment. In turn, over the last 20 years, there was a steady rise in the number of small and medium-sized businesses, with a shift from a focus on R&D to R&D as well as manufacturing. The cluster is now home to over 5,000 KI knowledge-intensive companies, as well as a number of non-corporate knowledge-intensive research organizations, including, for example, the MRC Laboratory of Molecular Biology, the Wellcome Sanger Institute, the Babraham Institute, and the Addenbrooke's Hospital. Contributing to the vibrancy of the cluster is also a number of international tech giants who have opened offices in the Cambridge city. Some of them are Amazon, Microsoft, Apple, and Samsung. The figure that is perhaps most revealing of the vibrancy of the cluster is the 20 unicorns, so $1 billion companies that have been created in Cambridge since the start of the phenomenon. If we examine the size of the Cambridge cluster by decade, we can see that the process, though, has not been linear. The significant growth in employment from the 1980s to the early 2000s was followed by a slowdown during the mid-2000s, which was caused primarily by reductions in high-tech manufacturing. Growth then resumed in the late 2000s, with strong growth during the last decade, driven by fast expanding ICT and life science sectors. And the fast expansion of the ICT and life science sectors in Cambridge meant that their contribution to total corporate employment in the Cambridge cluster has gone up significantly over the last decade, as we can see in this table, with sectors such as software development and publishing, IT and computer services, and biotechnology R&D playing an increasingly dominant role. Behind the growth of the Cambridge cluster is the fact that different technologies in the areas of biotech, infotech, and nanotech have converged over time to give rise to groundbreaking technologies such as biosensors and biochips. Indeed, the Cambridge cluster has witnessed a phenomenal transformation in its sectoral composition, with an increasingly wider spectrum of sectors and technologies, from a specialization in scientific instruments and computing in the early years to a much broader range of technologies, including nanomaterials, drug modeling, and, as we have discussed earlier today, most recently, artificial intelligence and machine learning. So, as part of our research, we've also been mapping the location of Cambridge-based companies operating in the life science and ICT sectors, the largest knowledge-intensive sectors in the Cambridge cluster, with the aim of understanding the geography of the cluster. We are providing here an example for the life science sector in the latest year that we have available, 2019-20, as well as the equivalent version for the ICT sector. And what we find with our analysis is that the geography of the cluster does matter. And it matters because we find that life science and ICT companies tend to be co-located with other similar companies, with agglomeration benefits, including access to a rich pool of talent, availability of specialized investors, and transfer of tacit knowledge. We also find that these companies are concentrated near the center of Cambridge and around some of the main science campuses in the city region, which is one of the main features of the geography of the Cambridge cluster. So science campuses have grown in number and have today become increasingly specialized. Here we are providing some examples of campuses in the Cambridge cluster. So when we talk about life science campuses, we're thinking, for example, about the Baberham Research Campus or the Cambridge Biomedical Campus. There are also campuses with a focus on information and communication technologies, such as the St. John's Innovation Centre. And we also have campuses with a more balanced portfolio of knowledge-intensive companies. And here I'm thinking particularly about the Cambridge Science Park. So a major role for the science campuses has been to provide the neutral space to enable effective interactions within the Cambridge innovation ecosystem. A noticeable feature of some of these campuses is that the investment required to develop them has been secured from extensive public and increasingly charitable funding over a number of years. The Wellcome Genome Campus, the Baberham Research Campus, and the Cambridge Biomedical Campus are but a few examples of campuses that have been developed through a robust partnership between the public and private sectors. The main science campuses in and around the city of Cambridge are summarized in this slide, which shows, as I mentioned earlier, that these campuses have grown considerably over time and do vary in composition as well as specialization. So to conclude, what can we say about the future of the Cambridge cluster? Well, on the bright side, the prospects for future economic growth look encouraging. The Cambridge cluster has many employment concentrations in fast-growing sectors such as life sciences, ICT, high-tech manufacturing, which have performed well through the COVID-19 pandemic. On top of this, AI and fintech companies are growing their presence in the area and are contributing to the vitality of the innovation ecosystem. Last year also saw the demand for laboratory space in Cambridge reaching the highest level for 5 years, despite the disruptions caused by COVID, while UK biotech companies raised a record £2.8 billion in equity finance. However, the success of the Cambridge cluster going forward depends on a lot of moving parts. For example, for people who are a bit familiar with Cambridge, traveling across Cambridge has become increasingly difficult, while buying a house in the city is now a dream for many. And our research suggests that Cambridge-based companies tend to regard transport and housing-related pressures as major constraints to their future growth, framing this issue usually as one of either Cambridge or relocating overseas. So the outbreak of the pandemic itself has also brought a number of additional challenges for the Cambridge economy, which hinges on close-knit interactions among its actors. All these challenges, as well as other challenges, suggest that further research is needed, and we are exploring a fascinating research agenda looking primarily at the evolution of the Cambridge business base, as well as the interactions between the different communities within the innovation ecosystem. We will be delighted to discuss any of these issues with you in greater detail. Thank you very much for your attention.
Thank you. Anybody have any questions? I have one if no one else does. experiencing something similar to Silicon Valley, where a lot of the people are just leaving because they can't afford to live there anymore, and including the companies themselves?
Yes, indeed. I think, Pete, if you want to add something, but it's fascinating actually how close the two experiences are, in the sense that my view is Silicon Valley is about 5 to 10 years ahead of Cambridge. So in a way, we can learn a lot from what is happening in Silicon Valley. And indeed, some of the same issues are happening already here in Cambridge. And today I touched upon just a couple in terms of a shortage of infrastructure, very expensive housing. And so I think for us, it's very important to learn from what is happening in the US indeed, because the challenges are very similar.
It's also worth mentioning, Tom, that the academic community as well in Cambridge, academic salaries are not amongst the highest in the world. So the increasing cost of living is challenging the knowledge base, as well as not just the corporate sector's willingness to locate here, who probably can pay better. So I think this is exactly analogous to, as you say, the American equivalent phenomenon.
Thomas, may I ask a question?
Yes.
Very interesting presentation. I understood from the early days of the Cambridge phenomenon that Cambridge allowed the commercialization of IP without any interference from the university, which is a very, very different position than most universities and certainly most employers today. That's one point. And the second point is actually the Brookings Institute are now talking about trying to get people to places as opposed to, places to people, to build the equivalent of these hot tech spots, compared with the other way around by moving people in. I just thought I'd throw that in, and whether it was a true fact, the former of those facts, which I think it is.
Yeah, it's undoubtedly the case that the one of the factors, particularly in the early years, was the university's Cambridge willingness to have a relatively laissez-faire attitude to intellectual property. That's changed somewhat over the years, but I think that itself was very important in the formative part.
Okay. I believe that closes out this particular session.
I have a question, if you don't mind.
Yes.
Excuse me. Hi, Mr. Mohammed, how are you? More than welcome to joining our event. Unfortunately, Mr. Macro, who will be Assistant DG of the WIBO, it's ready to deliver the speech or presentation on time, because he will having some commitment. Please, maybe you can ask later. Maybe after the keynote speaker. Thank you so much, Mr. Mohammed. Go ahead, Tom, Professor Tom, to introduce Mr. Macro. Hi, Mr. Macro. It is our honor to joining our event. Our minister send you best appreciation and regard, while WIBO is supporting, I can call it the largest practitioner conference in the world, pop up from the Kuwait. At the same time, in conjunction with Entrepreneurship Week, while all the world celebrating with Entrepreneurship Week.
All right, Marco, I'll leave the floor to you. And he is the director of the World Intellectual Property Association, or organization. And we look forward to hearing from you. You have the floor.
Many thanks. And I would like the outset to thank for the opportunity to be here with you at the 2021 International Virtual Conference on Innovation, Technology, Artificial Intelligence, and Entrepreneurship today. I would like to thank Dr. Hanari Mubarak, Conference Director and founder, CEO of the Ecosystem Consultant, for inviting me to present in this keynote address. I would like also to extend my gratitude to His Excellency Mohammed Abdul Latif Al Farid, Minister of Oil and Highway education. And I would like to start saying that I was there in 2019, kindly invited by the Scientific Club of Kuwait to participate in the Kuwait International Innovation Fair. And I have only very good memories of my contacts with a number of institutions and colleagues working on the area of innovation, as the Kuwait Foundation for the Advance of Science and the Kuwait Institute of Scientific Research, among others that I have the chance to meet at the time in that occasion. And I do hope activities as the Innovation Fair can resume after the COVID-19 pandemic allow us to have these type of events, which contribution goes beyond the country, beyond Kuwait, and has an impact in the whole region. Allow me to say a few words. I know that it would be a very short presentation, but let me say a few words in my view in areas that are quite relevant to innovation and to entrepreneurship, both key areas of you meeting those days. The first one is when it comes to innovation, there are a lot of concern and doubts about how COVID-19 pandemic has affected innovation performance worldwide. And because of that, in the aftermath of COVID, commitments to maintain and to increase incentives to innovation is once again at the focus of attention. And in my view, that's right. We will see a few reasons why, in fact, giving the necessary attention to all the different incentives to innovations are timely nowadays. In the past decades, investments in research and development have consistently grown faster than economic output. For example, investments and efforts in research and development reach an all-time high before the onset of the pandemic, growing at an exceptional rate of about 8.5% in 2019, in comparison to the global GDP growth that was almost around 2.4% in the same year. 2017 and 2018 were also extremely important years in terms of innovation performance, in levels very close to the 8.5 that I just mentioned before was the situation in 2019. And as you can imagine, top 5 research and development spending economies in 2019 were the United States, followed by China, Japan, Germany, and the Republic of Korea. These 5 economies have been consistently the major economies performing in terms of research and development expenditures since 2011. But where the business have been in this same period in terms of doing their contribution and their part in terms of innovation? Well, business research and development expenditure, that is probably the largest component of research and development, grew by 7.2% in 2019, with an increase of about 4.6% compared to 2018. So it shows that it was not only public expenditure in research and development, but particularly the efforts made by the private sector, one of those main drivers of the growth in 2019. So one of the big questions in 2020, late 2020, and even in the first semester of 2021 is how we are in 2020. And when we start conducting our analysis for the global Innovation Index. One of the very good news about 2020 is that innovation was quite resilient, and we will see that the figures of IP filing in the different categories shows the same level of resilience during that year. And this is quite remarkable. We don't have all the data available about 2020, but there are some indications that initially, and when we start making our initial analysis, initial considerations make us to believe that they may be an important hit on innovation performance in 2020, and we were thinking about probably a 2.8% of the innovation increase, only compared to the very high level of previous year. However, initial data can tell us that we can be a little bit optimistic about 2020, and data that we have at our hand so far tell us that we can be optimistic for two reasons. The first one of this optimism is the very nature of the 2020-2021 crisis. I mean, the pandemic. As pointed above, the impact of the crisis have been highly uneven in different sectors. So a number of sectors have been increasing the activity in innovation, as is the case of telecommunication, software, and pharmaceutical, while other sectors like travel and leisure are certainly heavily affected. And second, budget allocations for the top research and development spending economies have been showing massive allocation of resources in different areas. And we know about private sector data about 1,700 out of the 2,500 companies that are the main drivers of research and development shows that we may be expecting from the private sector an increase of about 10% in 2020. So initial figures on 2020, about 2020, although not complete, tell us that we can be highly optimistic on the performance on innovation in that year. And data on IP filing goes in the same direction. We just released the World Intellectual Property Indicator Report 2021 the week before, and this, in a nutshell, shows that intellectual property filings were also, as innovation, very resilient in 2020. It shows that innovators around the world filed around 3.3 million patent applications in 2020. It means an increase of 1.6% compared to 2019. And this is probably more impressive, around 13.4 million trademark applications were filed in 2020, showing an increase of almost 14% compared to 2019. So it shows that economic activity, and certainly in economic activity, IP filings are a very good indicator, shows an enormous resilience in not only in terms of innovation, that patents are a good products, or the presence of those products in the market, what is normally reflected through trademarks filing. So this is used to highlight how intangibles and intangible assets continues to play a very important role. And because of that, all the effort that have been conducted in Kuwait and in other regions to put in place policies that promote innovation and entrepreneurship are going into the right direction. Let me share with you a few figures on the role of intangible, and in my view, quite what could be the trend in certain areas that probably requires new considerations. The first one is the following. We take the Standard & Poor's 500 companies, intangibles, including IP, accounts for an estimated 90% of the total market of those companies. What is remarkable, a few years ago, 20 years ago, the composition of the value of those companies was dramatically different, and certainly tangibles were the main component compared to intangibles. Now we have, as I mentioned before, 90% of the market value of those 500 companies are represented by intellectual property intangibles, or for intangibles in general, including intellectual property in intangible. So it is clear that in the different value chains, IP components plays every time a more prominent role. In 2017, we have done a study that shows, for example, in a number of products that were identified the role of IP, and we took the example of the iPhone 7, and in each one of the iPhone 7 that are sold worldwide, in the IP component of that product amounts to about 42% of the total value, showing without any doubt the impact of IP in the market of smartphones. But the same applies to coffee, that is also covered by the same report of 2017. What, in my view, is changing from the policy perspective is more and more of those big corporations can get benefit from the IP system in different ways, not only in the traditional way of using those exclusive rights to keep some fences from other competitors into the market. But more and more, a number of companies are using IP not only through produce rent, through different licensing agreements, but new ways of monetization, new ways of exploitation of those intangibles start to be seen in the market. For example, recently, American airline, the airline, big American company, puts its brand and related trademark and domain name as a collateral to secure $1 billion USD in the financing market. Or recently, the big Aegean insurance company, Aon, facilitate an IP-backed financing deals that combine amounts about $150 million US. So IP start to be used in ways that are certainly news, and those require certain policy consideration worldwide. For example, if this interest in getting IP as a collateral or IP as a mechanism to back certain access to research, to resources, continues to be an important issue, probably not only for big corporations, but also for small and medium-sized enterprises. Then we need to start considering what is required in order to be sure that IP can play that role in different jurisdictions. And there are a number of legal issues, but there are a number of other practical issues that, without any doubt, plays a very important role. So what we are doing in WIPO, what we are doing is making sure that we will continue working hand by hand with different governments worldwide in order to put in place the appropriate policies that will facilitate the IP system to deploy all the benefits that we know is able to produce and is producing in a number of key jurisdictions. But able to do that all over the world. It means in other countries where the impact of IP is not at the same level on those more sophisticated jurisdictions. But at the same time, we realize that the World Intellectual Property Organization has also a mandate to work with the private sector to be sure they are able to get benefit from the IP system, either through different mechanisms that facilitate access to the different IP categories, or either making sure that those businesses, including a small and medium-sized enterprise, has at hand the tools needed to get IP appropriate protection. And in that regard, forums like these are appropriate space for us to communicate the different work we are doing in that regard. Just to name one, this week we launched a new IP tool, an online tool that facilitates small and medium-sized enterprises worldwide to make a self-diagnostic of how they are in terms of IP. Let me finish in 2 minutes, Thomas, to be able to stay a little bit on time, telling you that in the Global Innovation Index 2021, Kuwait has the place 72, what is a quite important place because it reflects different efforts being made in terms of policies in the field of innovation. And more relevant is even the fact that it's number 10 among the countries of the Northern Africa and Western Asia, showing a very strong position in that regard. Now, not all can be positive. When you analyze certain indicators about the position of the innovation activity in the country compared to the GDP of the country, then the country performs below expectation. What means there are a number of challenges there that needs to be addressed for the country to improve in that regard. On the contrary, when you take the indicators available, you will see that if you take the efforts that have been done in terms of inputs and outputs related to innovation, the country is performing very well, is in the line that shows an appropriate performance. In my view, the GII brings a number of very positive news to the different actors of the innovation ecosystem in the country, and we remain available in case there is a need, interest, or will to work with us in order to explore other potential action and activities to improve that ecosystem in the near future. That's the role of the organization, the World Intellectual Property Organization, and certainly I would be more than glad to discuss with you in what could be those avenues of cooperation. And I'm sure my colleagues in the Arab Bureau that are always in contact with the national authorities, and in particular with the Ministry of Commerce and Industry and with the IP office in Kuwait, will be more than available to discuss options for cooperation. Many, many thanks, and the floor is back to you, Thomas.
Thank you, Marco. Excellent presentation. And there's a Q&A section at the bottom of the Zoom lens. If you want to ask a question, that'd be a good place to do it. Our next I'd like to introduce my next speaker, which is Amin Hababe, and he is a professor and holds a PhD in advanced manufacturing, and he works at Nottingham Trent University. Welcome, and the floor is yours.
Thank you very much, Thomas. Masā al-khair. Good evening. I would like to start by thanking Dr. Hanadi Mbaraki for inviting me, and also to thank all colleagues for attending this session. If I could share the screen, hopefully. I don't know if you can see my slides.
We can.
Okay. So the presentation will be about innovation case studies towards reshaping lives and society, which basically will discuss some of the projects and innovation we do within the Product Innovation Center at Nottingham Trent University. So it's just a quick introduction. Nottingham is famous with Robin Hood. So if you are visiting Nottingham, you are welcome to visit me, and I'll take you on a tour to see Robin Hood and the castle. And we have also Sheriff of Nottingham as well. We have a history of more than 170 years. This is our Arkwright building. It's one of the first buildings that host the university. And the Product Innovation Center is a multidisciplinary research in terms of medical, energy, sustainability, innovation, consumer products. And I'll show you some examples of the work that we've been doing in this area. So the Product Innovation Center has an enabling technology side, and it's got also the sustainability side, and also applications in terms of condition monitoring and Industry 4. And also recently we have introduced air pollution monitoring applications as well. So we try normally to add value to products, or create new products that actually will solve problems. And the way I look at innovation is that solving problems that could be recognized or maybe not recognized yet by the society, because sometimes you actually to observe somehow people actually use products or their needs. Sometimes people don't recognize actually they need a specific product or service, and this is part of the innovation, I believe, is to recognize there is a value to be added to a product or to introduce new products in the market. So I'll just talk about how we train our students, our master students, undergraduate and PhD researchers, and how we work in terms of our consultancy. We normally start with an idea, and in most cases, we'll try to take the idea all the way to commercial reality. And this is how we train our students in relation to entrepreneurship and innovation. And we try to integrate different skills and knowledge from the design, the brainstorming, prototyping, networking, the technical skills, the presentation, etc. So we try normally to create real scenarios, and sometimes in collaboration with commercial products, to be able to train our students to solve problems and create a product that we could be introduced to the market. So we work from advanced technology all the way to art. So there is artistic side as well. Artistic side as well, which we shouldn't really ignore. So we need to think about what added value we can introduce to a product. So in terms of case studies, I'll start with some case studies in wave, wind, and solar energy. And if you need more information about any of those examples, please let me know. I'm happy to share any papers or presentations available in detail. So the first one is the energy from waves. So this is ongoing work about developing the technology to harness wave. And one of actually renewable energy, which is still not well utilized very well, is energy from waves. And we've developed new technologies for that. And we've tested the technologies, and we work with industrial partners in relation to how much energy is produced and what is the payback period of such technology and so on. So this is an example of how we could work on renewable energy, building prototypes, testing them, and so on. Another example, also working with one of my students to develop a wave energy system using recycled components. In this example, we've used bicycle components to create low-cost, low-power wave energy generation system to enable people who are doing camping or in a small boat to generate electricity sufficient to charge a mobile phone and make emergency call, for example. And it's a very low-cost system. wave energy, also wind energy. We looked at different configuration of wind energy design, especially for the urban environment, how we could maybe create those sort of wind turbines on top of buildings or in parks, and make sure they are safe and they don't produce any sort of noise or flickering or shadow during operation. So we explored also different designs in relation to that. In terms of solar energy, I had the pleasure to visit Kuwait just before COVID. Actually, this is Dr. Isa Mshai, and we've had a joint project on looking at micro-scale solar energy panels design and cooling systems. One has been published in Cleaner Production, and one is still, we are working on it. On the right-hand side, there is the indoor solar cooking, which is an innovation basically to introduce solar cooking, but actually having the oven inside the house, which is sort of innovative technique using sort of clever arrangement of mirrors, which is again has shown different sort of have seen different attention from the international sort of newspapers and TV stations, and we hope also to test that in situ. The COVID situation fortunately prevented us from taking this project forward during the past 2 years due to travel restrictions. In terms of security, we worked with the police on developing technology to basically detect concealed object weapons and knives and so on. So this is an example of the technology using infrared thermography, and it was presented in the Daily Mail as well in terms of technology. So you can see the difference between the left-hand side image of the visual image and the right-hand side, the infrared, which shows a person hiding some objects underneath clothing. And this is part again of the innovation that we worked with the police on. Water leakage detection. So this is one of the examples to try to, in the dry countries, try to see if there are pipes, buried pipes underground, where it could be water leakage detection without having actually to sort of dig the ground to be able to see the pipe. So again, using infrared thermography, we've tested the system, has been very successful, and the next stage also to take it to commercialization. Consumer products. One of the products that actually showed a lot of interest in the media was actually replacing the concrete blocks in washing machines with plastic containers that could be filled with water after installation. And I don't know if you know, there is a huge weight that washing machines have because to balance the drum, and those heavy weights actually they cost a lot in terms of transportation. So the idea was, can we reduce the weight, and after we install the washing machine, we fill the weights with water, and in that case we are actually transporting very light product. And we've tested the first prototype. It was very successful, and we worked with this one with a small company in Nottingham who actually wanted support in terms of developing the prototype and the testing process, and basically develop the idea further. Also, we sometimes experiment recycling products. So this is a heater, which is basically was designed from a kitchen refrigerator. So a normal fridge, an old one. What we've done actually, we re-engineered it to become a heat pump, and we recycled an old radiator to become a geothermal sort of radiator. And in that case, we could produce, or we could produce 3 times the heating sort of capacity based on enhancing the coefficient of performance. And that was one of my students' projects, which was done a few years ago, and it was very successful. So it looked like a nice piece of furniture, but in fact, it's a heating system using an old fridge, recycled fridge. Medical applications. I apologize, there could be some images of needles, so apologies if you are sensitive to such images. So most people who go to the hospital will end up with a cannula inside a vein, which simply to administrate medication or be giving drugs or one of the issues sometimes is that there is a high number of failures, especially among children and women. And this idea started when actually my wife herself was in the hospital and she suffered from failure in cannulation. So at that time, we worked on a research project to address the challenge and try to reduce the risk of failure. One of the also technologies we developed for that is a vein locator system, and the one on the right is using a mobile phone technology, a small scale one, to actually to see the vein. And this is at the moment is a pending patent application. Also, we tried to develop different technology to see how can we see the vein so that actually the clinician could insert the needle without much difficulty. The cannula itself, we developed the intelligent cannula, and the patent now is granted in Japan, Europe, UK, and there is a pending application in USA as well, which is basically as a hydraulic low-cost cannula where it will feel the pressure of the blood and automatically withdraw the needle, so to ensure that actually the cannula or the tube stays within the vein. And that is in development now for commercialization with the commercial partners. So this is some of these prototypes we've done with the intelligent cannula. So the front part is similar to any other cannula, but the back end actually where the clever application happens to reduce the failure of cannulation. Also, it has different applications in terms of we designed it as a cannula, but what we discovered that there are so many applications for the same invention in the medical and veterinary applications. So one of it is the trocar for laparoscopic surgery, and that also I had a student working on the new prototype for the surgeries, and actually that also attracted significant attention, and this now the technology is again under development. Also, we looked at the sport and medical applications, looking at the infrared thermography, the thermal profile with the sport athletes who are exercising, to look at how to design better clothing or smart textiles, to actually look at the distribution of heat when they are exercising. Looking at the vibration, the effect of vibration of blood circulation, what happens if there is a specific tool that basically generates high level of vibration, what would happen to the blood circulation. So this is some of the research we've done in the past as well. In terms of wet water resources, this is an interesting application. What we've done here, we tried to generate water from air using recycled fridges, and that actually attracted significant attention as well, because basically you could use solar energy and fridges that people throw away to create water or to condensate water in areas where there is a lack of water. And we developed two versions of this technology. It's a simple technology, but very effective. And actually it attracted the attention of many sort of media, and CNN is one of them. And these the two kids here is actually my children in Tunisia when we visited the Star Wars studio, because this is where sort of the idea came from, which is basically Star Wars movies. And I thought, okay, can we use maybe old fridges and create the same concept, which is condensation? And actually it worked very effectively. In terms of sustainable products, I had a student working with me on mycelium mushroom roots to create products, sustainable products. This is a speaker, which is basically built from a very sustainable material, mushroom, the mycelium of the mushroom, and we managed to create products. I think I've got one on the shelf in my office and it's been in very stable conditions for more than 5 years now. So I'm very proud with what we managed to achieve in relation to the product here. Sustainable buildings, we look at infrared thermography, insulation of buildings. The left-hand side one is in a hot country. You can see the air-conditioned flat, for example, is very cold in comparison to the rest of the building. And the right-hand side, the UK one, and you can see under the window, for example, there's a lot of heat dissipation because of the poor insulation of a wall. So this is examples of how we could use infrared thermography to advise people about insulation. One of the other technologies we worked on is energy from flooded coal mines, using geothermal heat to heat buildings. And basically the water underground in the UK from the flooded coal mines, it's at a stable temperature, about 15 degrees. So we can use that with heat pumps to heat buildings. In the Gulf, probably we could use the seawater to cool buildings using the same technology, using a heat pump. So this is also technology could be transferable to hot countries for air conditioning. So in a very hot summer day in the Gulf, for example, you could use the seawater and the heat pump technology so that to make the air conditioning system more efficient and therefore save significant energy and reduce carbon emission. We looked at the different applications of intelligent buildings, trying to look at the ambient temperature, the sort of people's behavior within a building, and the energy sort of consumed or wasted. And this is one of the key applications in terms of energy in buildings. We also look at thermal storage, and this is a new innovation, and we call it the water snake, which is basically new technology working with one of our industrial partners to create a stratified thermal storage. And this means if someone is having a shower, for example, you could consume and enjoy the hot water without the cold water being mixed with the hot water. And that way you save more energy in that case, rather than you have to basically mix the water, then you feel it's too cold, and then you have to wait to heat the water again. So this is one of the technologies that reduces the entropy of the thermal storage, which makes the thermal storage much more efficient in that relation. Again, I'm just very quickly going through examples, but if you want any information about any of the examples I'm presenting here, please get in touch, and I'll be happy to share with you any information. Industry 4 as well, we looked at intelligent machines, condition-based maintenance, or condition monitoring of machining operations to enhance productivity, increase the reliability of CNC machines and production systems. And this is an example of looking at the infrared thermography at the tip of the cutter during machining, for example. And again, using artificial intelligence, we could look at condition-based maintenance of machines, bearings, belts. We look at when the machine is expected to have the maintenance, and therefore you reduce the cost of maintenance and you increase the availability of the machine. So in terms of smart cities, for example, we've done work about overcrowding, which is now becoming also important in relation to COVID and the density of people. But the application we had was in Hajj, looking at density of people in Mecca and Medina, and to look at sort of the distribution within the holy city as an intelligent application, as a safety application for the future. And it's applicable in football stadium, and now because of COVID, in a busy sort of area, shopping mall, the same technology also could be used. In terms of education, this is so we, for example, we developed small scale systems such as energy from flooded coal mines simulator. We built to teach our students about the technology. For example, here we built a small scale system using a fish tank and a small scale model of a heat pump, just for the students as well to understand the concept. And this was actually built by students for the students as well. So the idea is we want to develop something that becomes easy to understand, by the students and then be used by students as well to understand the technology. Another educational simulator with the patent was granted recently is about understanding the thermal insulation in buildings and how to use it for education for primary school or even university students. So the idea is using infrared thermography, using different insulation levels, students could look at the benefit of insulation, monitor the temperature, and then calculate or estimate the benefits of thermal insulation in buildings. And this could work for hot or cold countries, of course, depending on the technology of its heating or cooling application. So in conclusion, the first step of innovation is to recognize a problem or a need and the value added of a solution. And what I've learned actually from working in the design and innovation is that I'm always observant of any problems, any way I could enhance people's life and work on it. And at the moment we are working on a brain signal technology for the motor neuron disease sufferers. And we hope to create a product to help people who suffer from the illness, at least to communicate in the latest stage of their sort of illness. It's a very sad disease, and the patients who suffer from motor neuron disease will normally need a lot of help, especially in the last stages of their life, because they will not be able to communicate. So we're working on a technology at the moment in relation to that. And thank you very much indeed. I'm sorry if I took too much of your time. And this is my email. And if you Google NTU Product Innovation Center, you should be able to find me. And thanks very much indeed. It was a pleasure talking to you.
Excellent talk. I enjoyed it. I'm gonna put mine up now. Let's see here.
Thank you so much, Professor Amin. It is our honor to have one of leading inventor.
Thank you very much indeed. It's a pleasure to be
So
here.
I gather you don't sleep, right? That's the way you do all this, right? You're a sleepless machine. Well, I'm Tom O'Neill. I've been your moderator, and I have a presentation I want to provide you. And actually, it's really nice that everybody has kind of done my work for me and set up my presentation slides to be so aligned with what you're doing without us ever talking to each other. One of the things I believe in is certainly entrepreneurship and innovation. And this is a slide I show people because, you know, we all say the innovation-based economy can make everybody wealthy, but this is world GDP per capita for the last 3,000 years. So it clearly shows that since minus 1,000 till around 1900s, the GDP per capita was pretty much stagnant. And now if you look what's happened, this is blown up over the next 400 or just over 400 year, you can see what's happening. And it really, the Industrial Revolution really didn't have a big input on wealth per capita, but the innovation economy sure seems to be doing that. And I think the secret of that is there's smart people everywhere, right? I mean, ideas can come from anybody, any place. And right now with the new technology, you can do it from anywhere almost. So, and if you look at it, we still have a long way to go. That GDP per capita in US dollars is only about $6,500, but it wasn't even $1,000 for a long time. And the blue and the red lines is one's the high estimate and one's the low estimate, if you're wondering what the two lines are. And I like to show this to get things started. When you think about a regional economy, one of the things that I talk about the money and the way money flows, and this comes out of a business college, I think mostly, but we call bad money is money when you have in a community, you have to send outside to buy things, or when people you train and educate leave and go someplace else and go to another region and make that region more wealthy. Neutral money is the money that kind of circulates in the community. Again, the barber goes and buys lunch at the local diner, who goes and gets his hair cut someplace, and that money just circulates around. And the really good money is when you have people that are doing business internationally, or at least outside their town. They're bringing in money, and it helps everybody, not just the company that's bringing in money from outside their region by selling goods and services outside of region, but also it helps the neutral business, and it helps reduce the bad money going in because it replenishes some of the money that's been going outside of a region. So if you think about that in your economic development scheme, I think it helps people understand how to make things better. This is something I did as a university, with my university hat on. trying to explain to university administrators why we would do economic development and why we would want to patent patents and things like that. But you really got to start with a world-class research and facility that, we talked about Oxford and Cambridge and places like that. And we have the good universities in California. There's good universities everywhere, but there's also places that have smart people that aren't in university. I keep telling that. So you fund these things, people come up with good stuff. They create great technology and they create people with smart minds and are well-educated. Companies are formed. You help those companies grow and become successful with their product lines. You put them in a research part, you create jobs. And that usually gives back to the community, and that actually will take a long way back. That will fund your world-class research and facilities. So it's in your enlightened self-interest to do these things. This is the kind of three-dimensional pictorial image of that same thing. So you need top researchers and faculty, you need entrepreneurs who can take this stuff, you need money. It helps if you have a cluster. If you notice that the Cambridge example, they had industry clusters that seem to do better. People want to be around each other that are likewise. We had our IP person here. You need to understand how to do IP and the importance of IP and managing IP. And you need to really keep your top students engaged and keep them in your community. And then you do research, you generate the IP, you have a strategy to develop this stuff, do market research, commercialize it. And then the top of the iceberg is really the economic development. But I tell people, you can't start at the top. You got to build this infrastructure where you have these clusters and innovation districts that can really build true economic development for a community. And this is what my attempt to kind of talk about it in terms of ecosystem. I got my PhD in innovation and entrepreneurship ecosystems. And one of the things I learned probably when I did this about 10 years ago, everyone makes a bubble graph, right? And usually they put themselves in the center of a bubble graph, right? And I realized if you're going to do innovation, you need to put the entrepreneur and the innovators in the center of this bubble, and you help them become prosperous with all these things you surround them with, and the whole community will succeed, and you need intellectual capital, I think, to generate some new ideas in an innovation-based economy. Again, it comes from universities, colleges, nonprofits, research institutions, and other smart people in the community. But you also have the talent pool, not just the techies, but the C-level managers and execs that can go in and make these things become real. You need money, you need capital, financial capital for sure. Angels, VC, philanthropy, we saw that today. Banks, government, corporate partners, how do you do it? And I find you really need someone who gets it, your advocates and champions that say, why would you do this? Because you need to, right? What makes this thing work? Do you want to have a broad-based prosperity, or you want to just kind of keep going like you're doing? Usually someone's got to promote these things. They do take a long time to seed and really become successful. That's why I talk about this other stuff too, the resources you can do, the incubators, the SBDC, we call them small business development centers, other service providers that are kind of enlightened. Economic guarding is a term I use for supporting second stage companies. So it's good to do this stuff. And these little dashed lines, my attempt, the better these people talk to each other and hand off, between the different sources, the better you'll be. And if the entrepreneur's in the middle and you always think about how you're going to make them be more successful, the whole system works better. Start with why. I think this is a good quote. If you ever know Simon Sinek, he does the start with why. And there's, again, no power of change greater than a community discovering what it cares about. If you care about economic development, you care about it becoming an innovation-based economy, if you care about making a broad-based prosperity, then it makes it easier to figure out what you want to do if you get on the same page. And places like Austin and other people have figured that out a long time ago. They called it unity of purpose and consistency of action, I think is a word. So they all get together and decide what they want to be, like what they care about, and they put together a plan to make it happen. And this is Simon Sinek, so I'd recommend doing it. If you haven't seen the TED Talk, he's really always inspirational to me. If you know why you're doing something, then you can always figure out how and the what. But if you only know the what and the how, you're probably not going to be very successful. And this is something I throw in, and I'm talking about building entrepreneurial communities, not self-employed people. This is a graph of self-employed per capita in OECD countries, and you'll see it goes down by the percentage of self-employed people. The more you have, the less income per capita you have. And the reverse is true. Use this spectrum. I wouldn't show you this slide, right? Entrepreneurship and developing growth companies, the more the percentage you have that in your community, the higher per income will be, the higher per capita income it'll be. And this is all the developed countries, and it's also probably true at somewhat to the developing and emerging companies as well, or countries. And in Florida, I always throw this up. Well, why focus on startups and not just help the great big companies? Because this percentage here is self-employed. They're like in 30% of the companies, but only about 8% of the jobs. Stage 1 is 63% of the companies and about 44% of the jobs. And stage 2, which I'll define as 10 to 99, is 5% of the companies, but 30% of your jobs. So this is where you really create your net jobs. And if you're looking at a place like Florida or the US in general, they're pretty similar. Companies of 100 employees or less represent about 99% of all the companies and about 82% of the jobs. And I think innovation in small companies are everywhere. This is the heat map of the United States only, but this is where new jobs and new startups are coming. And you see the usual suspect, you know, the Boston's, New York, the Silicon Valley, but you also see places you hadn't thought about in the Midlands, like in Denver. And here, Naples, Florida, who would have figured, right? This is Chicago. You can see this, the red is higher density of activity, but these are where all the startups and growing small companies are located in the US. And so think about an ecosystem that has support for all these stage companies. Think about how to make them more successful when they're starting, get them when they're really young at stage 1 and help them all the way through to become a fairly significant large company and they're doing things on their own. And also develop your clusters, right? Think about the horizontal and the vertical stuff. Have a big broad base to help early stage companies, the small ones, have some also support for the second stage and then get them, some support all the way up to the very, very big companies. And what is your industry sectors? And Orlando, for instance, financial, tourism, real estate, and constructions are our big industry clusters with an emerging tech scene in optics, lasers, and modeling and simulation. And again, can you help? And this is a study I did about, I think, I don't remember whenever it was, but these are companies that started at the same time outside an incubator. And these are the companies that started at the same time in the same region, in the same industry sector that were in an incubator. So as you can see, the revenue increased and so did the jobs. Bigger number, grew faster too. And what do we try to do when we help these companies? The number one reason startups fail is because they're building something that nobody wants. And I was really happy to see, discover the problem first, and then you can discover how the solution is, right? Number 2 reason is hiring poorly. So again, these are things that people make mistakes with all the time. You can see the majority are these top 3 subjects. So as you're trying to help these companies become more successful, you can help them with these things, what they do badly. Don't let them make the same mistakes over and over again and be a drain on your resources in the community. And what you're trying to do, and this is, forgive me, this is a baseball analogy, and I forget maybe some people don't know what baseball is, but these are strikeouts, these are base hits, and these are home runs. These are your gazelles or your unicorns down here at the bottom. So what you're trying to do with these resources is shift the curve down. You're not going to eliminate strikeouts ever, but if you can make them fewer and get the base hits to be higher and the home runs to be higher, that's what you do when you put together these innovation ecosystems to help become more successful. That's the goal. Reduce your risk and actually reduce customer risk. Most techies, again, I'm an engineer by training, so I understand why we do this, but we think about risk in terms of the technology not going forward as opposed to no one wanting to buy it. So what you want to do in a lot of these ecosystems is really reduce the risk of your customer, right? Go out and talk to them and find out what they really need. Find out what the problem is before you provide a solution for it. And this is I like to kind of close on this. I think I got a little bit of time, but this is what it looks like. And forgive me because I'm a sailor and it helps me to do the analogy, but this is what you start off in the beginning when everybody has a great idea. It's just like the wild river, rat races you have and stuff, and people all over the place. But eventually, one of these or 2 of these folks will actually start getting their act together, and you can help them with SBDCs and entrepreneurship centers and things like that to figure out how they do this stuff. Before you know it, they're in the game, right? They're racing. They're here. Lined up with all the competition. The competition is heavy and they still have a huge chance of being kind of a failure or failing because they didn't do things right. But out of here will emerge some winners and they'll get better and they'll start having different things. You have to help them grow. You'll notice here, it's like 1 or 2 people in these boats. Now you're up to 5, 6 people. You have different roles for people got to provide, they have to grow themselves, become more of a CEO, learn to hire better, learn how to do accounting and learn to do all the things they didn't have to do before when they were all doing it together. And the goal is to get them to here, and you can still help them. I mean, at this point, the owner may not even be on the boat. Over here, the owner's there, right? Over here, the founder may be not even on the boat. He may be putting this thing together, and they're raising money, and you're doing different jobs. So how do you get them to go better? How do you know how to get them to where their customers are? How do you help them become successful at this stage? So I use this because they're all different. They all need different things at different times. So if you can right size your entrepreneurial ecosystem so you serve all these people, they won't have to leave your community to get the help they need. So have it all either local or have it so where they can get access to it. And this is another, forgive the water analogy, but this is what happens when you take a piece of barren land and drop some old oil rigs on it. And you can create this really thriving community now because there's structure there. There's way for people to build things. You'll see fish and dive sites. And this really was a piece of land that was providing no help to anybody until they decided to do something about it. And they put the infrastructure in and had a strategic plan to make it happen. And this is my last slide. I can say I am a nerd. This is what I like to close on. This is Klingon for danger laser radiation. So in case you're wondering what that meant. All right. And with that, I'll stop my sharing. And we have a total of like 2.5 minutes left for questions for anyone in this panel if you want to talk about things. There is a chat mode, again, a question and answer down here, which I don't see any right now, but I'm going to try to get us to, well, it's lunchtime here. I'm not sure what time it is for everybody else, but with that, I'll turn it back over to our host, Dr. Hannity. Of course, I have this coming on now. It's kind of interesting. Any questions from anybody? Okay.
Can I just ask a question, Thomas?
Yes.
Malcolm Parry, you've got some very, very interesting slides there. You put copyright on the bottom of them. Is any of that available to, if you're credited to promote that?
Oh yeah, well, I can make these slides available to everybody. I put copyright because someone actually stole my slide one time. I went to a conference and there it was.
Without your name on it?
Without my name on it, yeah.
Oh, bloody cheap.
So one of my lawyer friends told me, why don't you just put copyright at the bottom and then at least they got to ask you for it.
Okay, thank you.
Tom, can I ask a question if you have time for more?
We have at least 1 more minute left, yeah.
Okay.
But I'm not in charge of the conference. This is session, so.
You are the boss, so I thank you for letting me speak. Question, I really love the presentation. Just a question, since I have only 1 minute. How does your model of ecosystem compare to Dan Eisenberg model?
You know, I can't answer it real quick. I'll take it offline with you. It's a long answer. We only have like 1 minute.
All right. Okay. Thank you.
Okay. All right. Good. Thank you. Hadi, we're finished now. Right on time.
يا هلا يا هلا يا هلا يا هلا.
She's multitasking, I can tell.
Thank you so much, Professor O'Neill, for chairing the roundtable, and thank you so much for the keynote speakers for joining our conference. It is our honor to be part of our conference and celebrating with us with Entrepreneurship Week. I think now Alia will take care about next sessions.